So we're working on density cubes, okay? And this whole thing, by the end of this, you're going to be able to tell me about density and how it relates to other objects, okay? So what we're going to use is we're going to use these cute little things called density cubes. If you notice, they're all what?
Cubes.
They're all cubes. They all have the same. What do you think they all have the same? They all share one thing in common.
They all have the same size.
Okay, they all have the same size.
Maybe they
Okay,
have the same
so what do you call something when it talks about the size, the amount of space something takes up?
mass. Wait, no. Area?
Okay, kind of. Okay, it's kind of, but if you're thinking of three-dimensional, you're thinking of three-dimensional. If you're talking about three-dimensional space, it's talking about your volume. Okay?
Oh, okay.
So what we're going to do, we're going to talk about different things. We're going to talk about this one right here, which is steel. Okay? So you ladies are going to have steel, and you guys are going to have steel. Okay? So what I want you to do is we're first going to talk about, so right in your first box, you're going to write name and material, steel, S-T-E-L, excuse me, S-T-E-L. Okay? Your mass. How do we find mass? What do we use to find mass?
We use the
Triple beam balance. So please, you may walk around. Both of you two find the mass of this steel. You guys use the triple beam balance and find the mass. Okay?
So first we have to start. Oh wow.
Make sure it's on the divot, that little notch. So is that too much?
No. Not enough.
Okay, well, did you try, wait, before you do that, did you try the 200?
Yes.
Okay, so good job.
Too much.
Go back, there you go. Use your pencil. Sometimes if you use your pencil, watch this.
Maybe
You
40.
can do little slight movements like that and use your pencil.
No, that's too much.
Pretty nifty.
Hold on, let's wait till it stops. Oh wait. Oh, that's too much.
And I also told the other friends over there, oh, I'm so sorry, I totally messed it up. Use your pencil.
Okay.
You can do slider movements with your pencil.
Okay. We're probably gonna need this.
So, sorry.
Or wait, I have an idea. We could eat to 20 and then go do a lot of gray activities.
Okay, so you guys having a hard time?
Go back and then use a bunch of gray activities.
Okay, real quickly, what are you at on that?
It's too light.
Well, they're at the same. So what are you guys getting? Y'all are getting about what? So you're gonna add them together. So this is what? 100,
30.
30,
Wait, no, it's not even almost 30.
almost one. What is this one? 100, 30.
I'm not even out.
So could, okay.
We're in like the middle.
So what is this right here? That's 30.
It's too heavy for us.
Okay. So this one is,
Like right there.
so it looks to be, so if we were to take an average, so you guys are 130, you guys are about 128, right? So for all intents and purposes, so tell me about this. Okay, so go ahead and go back. Okay, so y'all were right on the money of 130. You guys were at 128. So go ahead and write your 128 grams, your 128, 28 grams. And what did I say y'all's was?
130
30 what, dogs?
grams.
Grams. Excellent. Okay.
So it was 128 grams.
Now, what do you know about this? So I have the exact same object. It's both a cube, has the exact same volume. Okay, right? How do you find volume? Let's look at your next column. Your volume. How do you find volume? And we're going to consider this a regular object. Okay, this is a regular. This would be considered an irregular. Okay, because it's not regular. Okay, how do I find this? There's a formula. There's a formula in science, and it's length times width times height. Okay, so above your volume, I want you to write length times width times height. Tell me another attribute about a cube. All sides and all faces are equal. So if I were to look here and measure, and this was 1 inch for my length, what would my width be?
inches.
1 inch by 1 inch by 1 inch. So 1 times 1 times 1 is what? 1 times 1 times 1.
3. 1 times 1 times.
That's adding.
Oh, it's 1. 1 times 1 would be 1 times 1.
1. So we've got 1 cubic inch. So you'd say 1 cubic inch. Okay, so now we've got steel, and I'm doing this with you. So we got about 130 grams. All right, so now, stop that for a second. Okay, so as you're talking here, but if we're talking about, if you're looking at this paper right here, and you've got mass and you have volume, okay, we have grams and we have inches. If I were to compare them, is that a fair comparison? Am I comparing apples to apples here? If one of them's grams and one of them's inches? No. So one of them has to change. So, without me going into the whole conversion and things like that, what this is, 1 cubic inch is equivalent to the same thing as 16.4 grams. Excuse me, yes, grams. So now, can I compare them apples to apples? I've got grams and grams, so I'm able to compare them, okay?
Yes.
So underneath your 1 cubic inches, I want you to write 16.4 grams. Now, let's compare them. Which one is larger, 130 or 16.4, or 16 and 4 tenths? Okay, so write that, so we can say our mass of our steel is greater than our volume. Okay? All right. Jack, would you do me a favor and open the cabinet and get the roll of paper towels, please? So now what I want you to do is each of you, I want you to put carefully, when I say go, not yet, carefully put it in your water. What do you think is going to happen?
It's gonna rise.
Do you think the cube itself, not the water, because water is going to rise because of the displacement. Thank you, sir.
I think it's gonna sink.
So do you think it's going to sink?
It's
Why is it obvious it's going to sink?
It's so heavy. It's
It
heavy.
is heavy. Okay, so carefully set it in there.
Okay.
Carefully.
I'm scared.
It's all right. Just set it in there. Okay. So what you're going to do on this last one, or excuse me, the next box, it says sink, suspend, or float. What do we do?
Sink.
Sink. Okay. Now let's talk about that vocabulary.
What is
Sink. We know what a sink is. What is sinking?
It drops.
It goes to the bottom, right?
To the bottom.
All right. Suspend. We don't know. Float. What do you think float is?
Goes to like
Okay.
stays at the top.
Exactly right. So if sinking was at the bottom and floating was at the top, what do you think suspending is?
In the
or
middle.
suspension?
In the middle.
It's in the middle. Good job. It's hanging. It's kind of suspended. It's not quite sure if it's not quite at the top and not quite at the bottom. Right?
I've seen that before.
It's not sure where it wants to go. Good job. All right. So over here, this last box we have right here is your volume. Is your formula. Density is mass over volume. Okay. So our density. Let's go ahead and plug that in. Is our mass. What was our mass? 130 grams. What was our volume? 16 and 4 tenths grams. Or 16.4. I know it's a lot easier to say 0.4. Okay?
16 or 130 grams
Over 16, which is our volume. Awesome. Okay, next one we're going to do the exact same thing. So we're going to go a little bit faster. And this one is PVC.
What is PVC?
You know PVC pipe. You've seen the white PVC pipe underneath your sink, and when people build houses, all of the white piping. This is what it is.
That's cool.
So let's go back real quickly and talk about something I did think about a while ago. Is both of your steels. You have the exact same volume, but what's different on yours? The mass. You're exactly right. So that has to do with the amount of that's the amount of matter inside. You have a little bit more concentration than she does. or you two guys do. Does that make sense? They have a little bit more because they have 130. You don't have near as much, but yet my volume is exactly the same. Okay, so let's see if this happens the same. So obviously my volume is going to be what? The same, because it's the exact same shape, right?
Yeah.
The exact same shape, right?
I noticed something in
Mhm.
here. When we both dropped it, it went to the side.
Oh, that's just because of the resistance of the water. Just like kind of like if you put a feather in the air and it does this.
Okay.
It's just the air resistance, whereas that's just the water resistance.
Okay.
So it's kind of pushing. Yeah, it just happens to be that way. Okay, so right here with these PVCs, they're the exact same volume. So the question is, will they be the exact same mass? Okay, you can walk around. Yes, so yes, go ahead and write PVC. PV with a Victor.
Oh, okay.
Go ahead and find your mass.
Go ahead.
There you go. It's too heavy, so you got to make sure you want to start it all the way at the zeros. Good job. Use your pencil. It's a lot easier. So what is it?
10 and 9 and a half. It's 10
Plus 9 is what?
and 19, so point and it's
What are you guys getting?
like 19, 18,
Okay, 18.
5/10, I think.
Okay,
I think it's
So go ahead and write-
18
so-
and 5/10.
so, but you guys have something different, so go ahead. Okay, so you have at 18.
We have 19 and 5/10.
Okay, so go ahead and write yours, whatever your true mass is. Okay, and this is good, grams, good. All right, so we have to skip our greater than or less than. So now we're going to fill in our
Volume.
volume. What is our volume? What did we decide our volume was?
Length.
Length times width times height. But when we converted it to grams, it ended up being what? 16 and 4/10. So write your 16 and 4/10. And don't forget your grams. Okay, so which one is greater?
8.
18, okay. So the other person, now put your PVC in there and see what happens.
Wait, shouldn't we take out the iron?
It's all right. We're not going to put in there long.
That's so
Okay, but nevertheless, it what?
It sunk.
Or sank to the bottom, right? So it sinks.
I did too.
All right, so let's fill in our formula. So what's going to go on top? It's our mass. What was your mass? So go ahead and fill in your mass. It was. Yeah.
It was right there.
All right, next one we're going to do
Wood.
oak.
Oh, wood.
Okay, so oak is O-A-K. O-A-K. Okay, so find your mass. Good job.
Just 2 months. So 10. There we go. Okay, now.
Good job with your pencil.
No, go back.
So what was your mass?
10 and 2.5.
So 10 plus 2.5 is?
12
Okay, what else?
it's 13.
Okay, so write it down. say 12.5 grams. Whatever your, okay, now what is our volume? 16 and 4 tenths, or 16.4. Which one is larger?
Volume.
Okay.
Oh yeah, it is.
So our volume is bigger this time. So far our volume has not been, our mass has been larger. What's been the result when our mass is larger? So this time our volume is larger.
I think
So it'll float. I think it'll float. I think
Okay,
it'll float.
take your wood and try it.
It floats.
Okay, it floats. Okay, go ahead and take your wood out and put it on the paper towel. Okay, why do you think that we want to take the wood out?
because it can.
Not only that, but what eventually it'll start, well, it'll rot, but we won't leave it in there long enough. It'll sink because it ends up absorbing water, right? So what is that doing to my cube? If I'm absorbing water, what does the word absorb mean?
It's
Keeping or holding, okay?
and it's it'll make it a bigger mass because it has absorbed it.
Exactly right. So I'm just going to use this one. So if I were to absorb water, just like this paper towel, if I were to weigh it or find the mass of it, let's say it was 2, I put it in the water, is it still going to be 2?
No,
Why?
Because it has absorbed the water.
It's absorbed and taken in, and so therefore it's increased its what?
Mass.
Its mass. Okay? So let's go right here. Good job, guys. So float is the action of it.
Yes.
Let's do our density formula. So mass goes on top. So it's So let's talk about this, what we've seen so far, okay? When you're looking at these density cubes, okay? You've got steel, PVC, and oak. Steel, the what one? The mass was bigger, right? PVC, what one?
The
mass.
The mass. What one on the oak?
Volume.
The volume.
Yeah.
What do you notice about the action? If my mass wins, what's happening?
It sinks.
If my mass wins, what happens?
It sinks.
If my volume won, what happened?
It floats.
It floats. Okay, so down here, let's do this. I'm going to show you a funny and cool thing. Okay? Right? Mass goes on top, volume is on the bottom, right? Watch this. If my mass wins, what's going to happen if my mass wins? Watch this. If my mass wins, it's going to sink. So if the volume wins,
That's cool.
I know. If the volume wins, it's going to, that's pretty cool, isn't it? So, what I would like for you to do is I would like for you to do the exact same thing as we just done with this. And before you put it in there, I want you to predict if it's going to sink or if it's going to float. You know what? I'm not going to do wood. I'm going to do acrylic.
Ooh.
It's like a mirror.
There you go. I'm going to do acrylic. Because we know that most wood what?
I mean,
Most wood, thank you. So, this is acrylic. It is a little bit different. It's just the way they buffed it. It's the exact same thing.
Okay.
Now, would buffing versus not buffing versus buffing, would that maybe increase or decrease the mass? I don't know. It'd be interesting to see. We're going to find out. So, what I want you to do is I want you to do this by yourself.
Okay.
Okay? I'm also going to show, this is a diagram. We talked about mass going up. Excuse me, mass. If the mass is too much, it's going to sink. If the volume wins, it goes up.
Wait, do we measure it?
Okay.
Only the one. Too much?
Okay, so what are y'all looking at? Make sure it's in your little divot. There you go.
It just needs like one more, not even one.
Good job using your pencil.
I'm not moving. Move that pen.
has to be maybe 10.
Well, does it go up to 10 right there?
Yeah, it does.
Okay.
Exactly.
So what's 10 plus 10 plus 10?
20.
What about you guys?
Got 90.
All right, so this is interesting. They got 20, you got 19, so maybe we can deduce that maybe it makes a difference if it's buffed or not, right?
It does.
Okay, so go ahead and fill in. Good job, Arango. Making sure you have your measurements on there.
Wait, what? Did I do that?
Mhm.
Oh, okay. I did. I forgot I already
So
did.
I'm going to time out for a second.
Okay.
19 and 20, is one of you guys going to float?
No.
Why?
Because it's greater than the volume.
Great. Because what has to happen, if you want something to sink, what do you need to make sure you're doing?
Using
Make
heavy
sure that the volume
is more
or is less.
is
Okay? No, your
No,
volume, if you want your
Oh, yes.
volume, if you want your volume to win, you are going to get it to
slow.
Bigger than
exactly. So this is all density. So one of your research questions was, how does volume relate to density? And how does mass and volume relate to density? This is exactly what it is. All of these, except we don't have the wood in there, both of those down there are more dense than the water. What can we say about this?
it's less.
Less dense than the water because it floats. And all of this has to do with density in the sense of density is your formula is density is mass over volume. Okay? You can have, and you can even talk about density when you talk about other things.
Oh, it's still
Okay?
wet.
When you talk about these, believe it or not, you asked me a question while ago about this word. Believe it or not, there's two liquids in here. Can you see them?
Yeah, a little bit.
Can you see them? Can you see my two liquids in here?
Yeah. No way. That's so cool.
Two liquids, right?
Yeah.
It's very easy to see, right?
That's so cool.
Is it very easy to see two liquids in here?
No, not really.
This is my example of suspension. I poured two liquids in here. They don't separate. They are neither sinking or floating.
Can we see that one?
Hang on. This is yes, that is suspended because they're in the middle. Okay?
Yeah, there's a
So what
bunch
can I
of
say about the
bubbles.
density of this? This blue one is what? More dense than the whatever
oil.
this is, the oil or clear liquid or whatever that is. Okay? Now you have three objects here.
Three. Whoa.
You have the water, you have the confetti, and you have the foam. What can I say about the foam?
The foam is less dense.
Less dense. So now let's look at your equation. So tell me about your foam. What's winning? The volume. Great. So my volume is bigger than my mass, therefore it's going to float. Excellent. Tell me about the density. Tell me about your mass and your volume here with the sparkles.
It's
Okay, it's more dense than anything, right? Because it's on the bottom. So therefore, tell me about the formula that we're working on. Tell me about the formula. If you want it to sink, what needs to win?
the volume.
The
I mean the mass.
If you want it to win and to sink, what do you have to do?
You have to
Your
make
mass.
it-
So my sparkles have more mass than volume.
And then the clear liquid is the suspense because it's in
Well,
the
it's
middle.
not. This one's not really suspended. It's what is happening because your water. If your water was suspending, it would be all the way through everything.
Okay.
See, your foam is sitting on top. Okay, like this. Can you tell me a clear separation of the two liquids?
No.
No. There's no clear separation of these two liquids. That's why it's suspended. Okay. Is there a clear separation of these two liquids?
Yes.
Absolutely. So therefore, there's no suspension going on. There's a definite difference in densities of this. Okay? His mass is larger than this mass. Even if you're comparing this mass is larger than this mass because it's on the bottom and it's sinking. Okay? Okay, so going back to your acrylic, not putting it in water, let's predict. Look at your numbers. Which one's larger? My mass or your mass is larger because 20 is larger than 16.4, 16 and 4/10. So it should what? Sink. Excellent job. And then you can absolutely put that in your formula, which is your
Yeah.
20 over 16 and 4/10. And if you want to put it in there, what should happen? Let's see. And it correct. And you guys are correct.
And it landed on the
Excellent job.
PVC.
All right, great job. Hey, go ahead and press stop.